Welcome to Chapter 5. We're in Section 5.1 today, and we're going to be talking about the fundamental trig identities. Now, you already have these, but we're just reviewing because we're going to be using them again in Chapter 5 quite a bit. So for the sine of theta, remember it's the same as 1 over the cosecant of theta. Cosine is 1 over secant theta, and tangent is 1 over the cotangent of theta. Cosecant, 1 over sine theta, secant 1 over cosine theta, and cotangent is 1 over the tangent of theta. The quotient identities, tangent theta is the same as sine theta over cosine theta. Cotangent is cosine theta over the sine theta. Don't forget, we also have cofunctions. You can use pi over 2 minus theta in place of 90 minus theta. One is in radians, the other one's in degrees, but they're cofunctions. So sine of 90 minus theta, the cofunction, is cosine of theta. Cosine of 90 minus theta, its cofunction is sine theta. Tangent's cofunction, cotangent of theta. Cosecant's cofunction is secant theta. Secant's cofunction is cosecant theta, and cotangent's cofunction is tangent theta. We have our Pythagorean identities. You want to keep this as a reference. When we talk about even and odd identities, the only ones that are even, are cosine and its reciprocal secant. All the others are odd. Remember, an even function. For even, for example, cosine of negative theta is equal to the cosine of theta. The cosine of the negative angle and the positive angle are equivalent. Same thing for secant. Secant of negative theta is the same as the secant of theta. For an odd function, it's -1 times for the even one. So the sine of negative theta is -1 times the sine of theta. Tangent of negative theta is -1 times the tangent of theta. Cosecant of negative theta is -1 times the cosecant of theta. And cotangent of negative theta is the same as -1 times the cotangent of positive theta. The only ones that are even are cosine and its reciprocal secant. So looking at problem number 1, use the value that the secant of theta is -3/2 and the tangent of theta is greater than 0. So now, it's easier for me to reference cosine. Cosine, the reciprocal of theta, is going to be -2/3. Now, if cosine is negative and tangent's positive, they're all positive in quadrant 1. Only sine is positive in quadrant 2. Only tangent is positive in quadrant 3, and only cosine is positive in quadrant 4. So because cosine's negative and tangent's positive, we have to be in quadrant 3. Draw your triangle in quadrant 3. Cosine adjacent over hypotenuse, 2, 3. The radius at hypotenuse is never going to be negative, so the 2 has to be the negative. Use that Pythagorean theorem to find the missing side. -2 squared plus b squared equals 3 squared. 4 plus b squared equals 9. B squared equals 5. B equals the square root of 5. Now, we have two solutions, the positive and a negative. So because we're in quadrant 3, both legs are negative. The root 5 is a negative root 5. So let's find our trig functions for theta. The sine of theta, opposite over hypotenuse, -√5/3. The cosine of theta, we already know. It's -2/3. The tangent of theta, -√5/2, which is √5/2. The cosecant of theta. You could use hypotenuse over opposite, or just take the reciprocal. It's negative 3 over root 5. Rationalize, multiply by root 5 over root 5. So you get negative 3 root 5 over 5. We already knew the secant of theta is negative 3 halves. That was given to us. And now for the cotangent of theta, that's going to be 2 over root 5. Rationalize, multiply by root 5 over root 5. You get 2 root 5 over 5. And there's our 6 trig identities given that information. Now, the next page, we're going to be talking about simplifying. So I did give you a review sheet with all of these on it that you should print off. Make sure you have it. It's going to make the next part a lot easier because you're going to keep referring back to these. We're verifying, or excuse me, we're simplifying here. So what we're going to do is we're going to look, and we're going to take this, and we can see we have a common factor of the sine of x. So I'm going to factor out the sine of x. So when I do that, I'm left with cosine squared x minus 1. Now that cosine squared and then the 1 look familiar. If we think back to the previous page, our Pythagorean identities, sine squared x plus the cosine squared x equals 1. Now, if I isolate the sine x, actually I'm going to kind of rewrite this a little bit differently. I'm going to get cosine x minus 1 on the same side. So I'm going to subtract the sine of x, sine squared of x, for both sides. I'm also going to subtract 1 from both sides. So what I get is I have cosine squared x minus 1 equals negative sine squared x. Now, this was a rewritten Pythagorean identity. Instead of writing cosine squared x minus 1, I can put negative sine squared in its place. So we have here sine of x and negative sine squared x. Positive times a negative is a negative. Sine of x times sine squared is the same as sine cubed x. There's our simplified expression. That is equal to negative sine cubed x. This takes a little bit of practice. For B, they have the common factor of cosecant of x. So I have the cosecant of x, and when I factor that out, I'm going to get cosine squared x minus 1. Now, I already saw in the previous problem, cosine squared x minus 1 is negative sine squared x. So I have the cosecant of x times the negative sine squared of x. I think we can keep going because cosecant is the same as 1 over the sine of x times, and that's negative 1 times, and sine squared. That's the sine of x times the sine of x. I'm going to write it like this because you can see a sine of x on the top and a sine of x on the bottom cancel out. So we're left with negative 1 times the sine of x, or negative sine x. And there is our simplified expression. Like I said, we're going to be practicing this quite a bit in the first few sections, so it's going to take some time to get used to. Secant squared theta minus 1. Now, they want us to factor it. So what we can do is a little bit of substitution here. Instead of putting secant of theta, I can write that as x. So if I'm doing that, what I'd have is instead of secant squared, I'd have x squared minus 1. That's much easier for me to factor. What that does is that gives us x plus 1 and x minus 1. So now, if we substitute that secant theta back in, we're left with secant theta plus 1 and secant of theta minus 1. That is factored. For B, kind of a similar problem. Instead of writing cosecant of x, I'm going to make that just a y. I just want to use different variables. So what we have here is we have 2y squared minus 7y plus 6. And we're going to factor this quadratic. So when we do that, we have a 2y and a y. Now to get to that positive 6 and the negative 7, we're going to have a minus 2 here and a minus 3. That's what you get when you factor that quadratic. So now, putting cosine x back in for y, it's 2. Cosecant x minus 3. And the cosecant of x minus 2. And there we go. This is all leading us to starting to solve and verify and doing all the other things. It's all we're talking about is rewriting right now. For C, instead of writing tangent of theta, I'm going to replace that with an x. So what that gives me is it gives me 4x squared plus x minus 3. And we can factor this quadratic. That gives us a 4x and an x. It gives me a minus 1 and a plus 3. Actually, that's a plus 3. Excuse me. That's a plus 1 and that's a minus 3. So now I replace x with tangent theta, so it gives me 4 tangent theta minus 3 and the tangent of theta plus 1. There's our factors. I know some of you might not be getting this right now, but we'll be practicing. This is not the only time we're going to see this. Once again, instead of writing the cosine of x, I'm going to replace that with a y. Just use a different variable. So what we have here is 1 minus y squared. Now when we factor that, we get 1 plus y times 1 minus y. So that's going to be 1 plus the cosine of x, 1 minus the cosine of x. And that is factored. Let's do a couple more. Now, they're going to get a little bit more complicated here. Here we have a cosecant squared and a cotangent. We have to do some more substitution. I'm going to rewrite the cosecant squared because I have the Pythagorean identity that tells me that that says that 1 plus the cotangent squared theta, or x, equals cosecant squared x. So what I can do is, instead of writing cosecant squared, I can put 1 plus cotangent squared x. So 1 plus cotangent squared x minus the cotangent of x minus 3. We wanted to replace the cosecant squared because we could rewrite that. We couldn't do anything with the cotangent. So now when we combine our like terms, cotangent squared of x minus the cotangent of x minus 2. Just like before, I'm going to do my substitution. I'm going to make the cotangent of x equal to y. So we're given y squared minus y minus 2. So we factor y minus 2, y plus 1. And then we go back and put cotangent of x in place of y. Cotangent of x minus 2 times the cotangent of x plus 1. And that is fully factored. Another problem for B. Once again, I have a secant squared and a tangent. I want to get them all to be tangent. I'm going to rewrite the secant squared. So we have that Pythagorean identity, but 1 plus tangent squared theta equals secant squared theta, or x, it doesn't matter. So instead of writing secant squared, I can put 1 plus tangent squared x plus 3 tangent of x plus 1. Combine your like terms. Tangent squared x plus 3 tangent of x plus 2. Let's make that tangent of x equal to y. So we end up with just y squared plus 3y plus 2. So when we factor that, we get y plus 2, y plus 1. So now we replace the y with the tangent of x. It's the tangent of x plus 2, tangent of x plus 1. And there are our two factors. All right, we're going to stop there for now, and we'll be back again to do more practice with these and simplify. Thank you, and have a nice day.